All right, so now I want to show you all how to use a sign chart to determine where a function is greater than or less than 0, simply meaning whether or not the function is positive if it's greater than 0 or negative if it's less than 0. So we have the function here, and this is number 1 on page 2 of your handout, and we're looking for where this function is going to be greater than or equal to 0. So in other words, where the function is positive. And if you already have caught the preview of this video during the lesson, then you know that the graph will be positive where it's above the x-axis. The graph will be negative when it's below the x-axis. But now we don't have a graph to go off of, so we need to determine where it's going to be positive and where it's going to be negative. Also, if you remember from the graphs, it's only going to change signs either at the x-intercepts or where there are restrictive values. So basically when it's going across your vertical asymptotes, when the function is undefined. So we need to know what the zeros of the factors in the function are. So this one is already given to us in factor form, and we're going to use something that's called a sign chart. So here's how you create your sign chart. Over on the left side, you're going to write your factors in a column. So we'll take x minus 4, we'll have x minus 5, and we'll have x minus 6. And these will be our factors in our sign chart. Now, underneath our sign chart, we're going to use a number line. We're going to draw a number line that goes from negative infinity over to positive infinity. So let me zoom out a little bit so we can see the whole thing. So going from negative infinity to positive infinity is what our number line does, and we put that under the sign chart. So from negative infinity to positive infinity. So now on our sign chart and going down to our number line, we'll find all of our zeros of our function. So our zeros are going to be 4, 5, and 6. So 4, 5, and 6 for this function. So on our number line, we need to see 4, 5, and 6, and we're going to use a solid line at 4, 5, and 6 because that is where the graph is equal to 0. So there's 4, here's 5, and here is 6. So now we have our number line divided into 1, 2, 3, 4 sections, from negative infinity to 4, from 4 to 5, and from 5 to 6, and from 6 to positive infinity. And then finally, we're going to use those to determine where our function, what f of x or p of x or whatever your function is going to be positive or negative. So this is what your sign chart looks like before you begin to put the information in. So now, our first interval goes from negative infinity to 4, and we need to determine if it's going to be positive or negative for each one of these three factors. So if you plug in a number that goes out towards negative infinity, like negative 100, this will be negative. Negative 100 minus 4 is negative. This will be negative, and this will also be negative. So when we multiply now, a negative times a negative times a negative, we'll end up with a negative. So our function value from negative infinity to 4 is going to be negative here. So, but we want when it's greater than or equal to 0, so that won't be included as a part of our answer. Now, the next section, going from 4 to 5. So we need to choose a number between 4 and 5 to test if the function will be negative or positive. So a number between 4 and 5 could be like 4.2, 4.3, 4.5, as long as it's between 4 and 5. So if we choose 4.5 now, 4.5 minus 4 is going to be positive. If we choose 4.5, 4.5 minus 5 is going to be negative, and minus 6 will also be negative. So now we have a positive times two negatives. This will give us a positive value. So this is a positive section here, which we want to keep. Now we choose a number between 5 and 6. So that can be 5.5. 5.5 minus 4 will be positive. Minus 5 will also be positive. And then minus 6 will be negative. So this section of the function is going to end up being negative. So, and then finally, if we choose a number that's greater than 6 going out towards positive infinity, if we choose 10, 10 minus 4 is going to end up being positive, positive, and positive. So we only want to know what the sign is going to be when we plug those numbers in. So we end up with a positive here. Now, if we go back to our problem to find our final answer, we only want the sections that are greater than or equal to 0. We use solid lines to remind us that at these endpoints, these will be included because we want equal to 0. So from 4 to 5 inclusively is going to be, so our solution now is going to be from 4 to 5 inclusively, and then it's also going to be positive from 6 to positive infinity. The 6 is included, infinity always gets a parenthesis because those were the positive sections of our function. The negative sections are not included because, again, going back to the problem, we want it where it was greater than or equal to 0. So this would be our solution for number 1. All right, so now we have our sign chart already set up for number 3. We took our factors, we put them on the left side of the sign chart. Our zeros at -4 and 9, we put those on our number line. These will also divide our intervals where the graph may possibly change signs. And now we check each section of the graph from negative infinity to -4, from -4 to 9, and then from 9 to positive infinity to see where or if the function will change signs, because this time we're looking for where the function is less than or equal to 0. So this time we're going to keep the negative sections. So the first thing you can notice here is that x minus 9 is squared. No matter what we plug into this factor, it's always going to get squared, so it's always going to be positive. So we can just put positives across this row for x minus 9 squared, and now we only need to check the sections for x plus 4. So x plus 4, if you plug in a negative number in this interval, say -10, -10 plus 4 is going to end up being negative. And then we choose a number between -4 and 9, let's say 0. So if we plug in 0, we'll get a positive. And if we plug in other numbers greater than 9, we will get a positive here. Now we check for our sections that are less than or equal to 0. Positive times a negative, the function will be negative here. So we keep this section of the graph, but everywhere else, the function is going to be positive. It's going to be equal to 0 at 9, but in the rest of those sections, it's going to be positive. So we will keep 9, but nothing else on either side of 9, because it's positive here and it's positive here, and we want less than or equal to. So we keep the 9 because it is equal to, so the 9 is good, but everywhere else over here on this side is not good. And then we keep this section of the graph as well. We keep from negative infinity going out to -4 with a bracket, and we shade everything in between. So our solution here is going to go from negative infinity to -4 with a bracket, and then the only other section that we keep over here is not by itself. So it's not parentheses from 9 to 9, it's just 9 by itself. All right, finally, let's flip over to page 3 and look at how to solve this inequality using this sign chart when it is a rational function that must be greater than or equal to 0. So still, we'll put the factors from both the numerator and the denominator in the sign chart, and notice that our factors will be x minus 5 squared. The x squared minus 1 can be factored again, so we'll put the linear factors in the chart. If we break down the x squared minus 1, we'll have x minus 1 and x plus 1 as our factors there. Then, filling out the rest of our chart, we see our zeros will be positive 5, positive 1, and negative 1. But also, these zeros will be undefined, because if you plug in 1, you get 0 in the denominator. So even though those are zeros for factors, those are zeros that are in the denominator. So we will not include those no matter if it's greater than or equal to or not equal to. You do not include your zeros in your answer. So if you draw your interval notation, the 1 and -1, if they are a part of our solution, they will both have parentheses, because remember, your domain restrictions have to be excluded. So on our number line now, we'll have -1, and this will be an open circle, and it will not be included because that is where we will have a vertical asymptote in our graph. And then we'll have one again at +1, so that will not be included. We use the open circles to just remind us that is not included. And then we have another one at 5. The 5 is included because it's in the numerator, and we want where it's equal to 0 as well. So now we use our numbers. We start out between -infinity and -1. That could be -10. This will always be positive. -10 minus 1 is negative. -10 plus 1 is also negative. So we see this section of the graph is going to end up being positive, which is what we want, greater than or equal to 0. So we shade here, keep that open circle there. Now, if we plug in a number between -1 and 1, like 0, 0 minus 1 will be negative, 0 plus 1 will be positive. This section will be negative. We don't want that. We want greater than or equal to 0. Now, if we plug in a number that's between 1 and 5, like 4, this will be positive. 4 plus 1 will be positive. So we have another positive section here. So we're shading. And if we plug in a number greater than 5, like 10, going out towards infinity now, these are also all going to be positive. So we continue shading through the 5, going all the way to positive infinity. So now our final interval, based on our number line here, we're going from -infinity to -1 with a parentheses, and then we're going from 1 to positive infinity, and of course they also get parentheses. So here's where our function is greater than or equal to 0. In other words, this means that is where the function is positive.